In Minecraft, there's a 1% chance that a spider will spawn riding a skeleton. Wait, no, it's the other way around. There's a 1% chance a spider will spawn with a skeleton riding it. This is a spider jockey. Now, while they are pretty rare, I've definitely seen a few in my many years playing Minecraft, but this isn't a Let's Play channel. I want to find out how many spawn eggs I should use if I want to see a spider jockey. Now, it's possible that I will get a spider jockey on the first egg, but this is fairly unlikely. Alright, easy question. What's the probability of getting the first spider jockey on the first spawn egg? Well, I already told you that a few seconds ago. It's 1% or 0.01. So I'm probably going to need more than one spawn egg. Alright, more difficult question. What is the probability that the first spider jockey I get is on the 5th spawn egg? This means I don't get any jockeys on the first 4 eggs, but I do get one on the 5th egg. To make this simpler, I'm going to say that when a spawn egg does not spawn a jockey, that is a fail, and if it does spawn one, then it's a success. You can either fail or have a success, so the probabilities of the two outcomes must sum to 100%. When the probabilities of two events sum to 100%, the two events are called complementary events. Either one event occurs or the other event occurs. Because a success and a failure are complementary, the probability of a failure is 1 minus the probability of a success. In this case, a failure has a 99% or 0.99 chance of occurring. Multiplying that together 4 times for each fail, we get 0.99 to the 4th power, which is equal to about 96%. This is the probability of getting 4 regular spiders in a row with 4 eggs. Then we would multiply this probability by the probability of getting 1 success to get the probability of the first success being on the 5th spawn egg. We can take the probability of 4 fails and multiply it by 0.01 to get a probability of about 0.96%. This means there's a 0.96% chance that I will get the first spider jockey on the 5th egg. This process can be generalized to the formula 1 minus p to the k minus 1 times p to get the probability of getting the first spider jockey on the kth egg. This equation takes the probability of a fail, which is 1 minus the probability of a success, then raises it to the power of the number of fails, which is the number of spawn eggs minus 1, because the last spawn egg is the success. Then, finally, it multiplies by the probability of the final success. This formula is known as the probability mass function, or PMF, for the geometric distribution. Okay, but wait, something's not quite right. If I increase the number of eggs I use, the PMF gives me a smaller value. For example, we know one egg has a 1% chance of spawning a jockey, but getting the first jockey on the 5th egg is 0.96%, which is less than 1%. Shouldn't the probability of getting a jockey increase as I use more eggs? The reason this happens is because the PMF tells me the probability of getting the first success on the kth egg. I want to know how many spawn eggs I should use to get at least one spider jockey. So for example, if I use 5 eggs, I want to know the combined probability of getting a spider jockey on any of the last 5 eggs, not just the last egg. Now, we could just use the probability mass function and add up all the probabilities for getting success on the first egg, and then the second egg, and then the third egg, etc. This would be one way to calculate what is known as the cumulative distribution function. As the name implies, this function finds the cumulative sum of probabilities of getting the first success for each trial. In other words, it tells us the total probability of getting a success for some number of trials. For the geometric distribution, there's a much easier way than adding up all possible scenarios. If I want to know, for example, the probability of getting at least one spider jockey when using, say, 10 eggs, I could instead start with an easier problem. What's the probability of not getting any jockeys? We know the probability of a fail is 1 minus the probability of a success. In our case, 1 minus 0.01 equals 0.99. So, the probability of 10 fails is 0.99 to the 10th power, or about 90%. Now, when we use 10 spawn eggs, we either fail every time or we don't fail every time. If we don't get all 10 failures, that means that we got at least one success. This means these events are complementary and their probabilities must add to 1. We can use this to find the probability of spawning at least one jockey in 10 eggs by subtracting the probability of getting 10 failures from 1. In our case, that means 1 minus 0.90438, which is equal to about 0.09562, or about 10%. This means we have about a 10% chance of spawning in a spider jockey with 10 eggs. This can be generalized to this formula, where x is the number of trials, in our case this is the number of spawn eggs, and p is the probability of a success. Note that 1 minus p is the probability of a failure, so the formula basically says, what's the probability of failing every time, and then asks what if that didn't happen. Alright, we're in the home stretch now, so what if I want to be 100% sure that I get at least one jockey? How many eggs should I use? Well, unfortunately, no matter how many eggs you use, there will always be a small chance that you will never get a jockey. If I use 1,000 eggs, there would still be a 0.004317% chance of not getting a jockey, but it's still possible that I don't get one. It's just really, really unlikely. Now, I don't want to be here all day, so I'll settle for a 99% chance of getting a jockey. How many eggs should I use to get a 99% chance of spawning in a spider jockey? To set this up, I can use the cumulative distribution function and set it equal to 99%. And we know that p is equal to 0.01, so we can plug that in and solve for x using a little algebra, and I get 458.21. So I should spawn in 458.21 spawn eggs. Except I can't spawn in 0.21 spawn eggs, so I'll round up to 459 to make sure I'm over the 99% threshold that I set for myself. 459 is equal to 7 stacks of 64 plus 11 more. Alright, now for the fun part. I build this little contraption to help me spawn in exactly 459 spawn eggs. There's a 99% chance that I'll get at least one spider jockey, and a 1% chance that this video will be completely boring. Now we just wait. Okay, so I forgot to set the time to be night, so the first jockey that spawned in on like the 5th spawn egg died. So we got a jockey, I guess, but that's boring. I'm gonna start this over. Okay, this time I set the time to be night, but it didn't even matter because the spiders like to climb walls and suffocate the skeletons, but at this point I don't care. Also, I got 2 jockeys right at the start again. Come on game, you're ruining the suspense. But we did get 2 more later. Okay, now all 459 spiders are spawned in, except the spiders keep jumping off the walls and dying, so there are many less than 459. But we got 4 jockeys, so we did it. Yay! Since there's a 1% chance of getting a spider jockey for each egg, we would expect to get around 4.59 jockeys, so our results make sense. Okay, thanks for watching. If you watched all the way to the end, leave a comment about which jockeys in Minecraft are your favorite. There are many options, and in Bedrock Edition, some baby zombies can ride like any mob, even other zombies. Okay, thanks for watching, see you later.